In the last example, we saw that the probability of at least one something can be a little tricky. Now, in this example, we were doing the probability of at least one success, and we saw that that's really a whole bunch of different combinations, and you have to find the probability of every combination and find out how many of them there are and then add them all up. It's way easier to use the fact that you know that the sample space's probabilities have to add up to 1, and then find the complement of at least 1, which in this case would be fail, 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 the pink one, and then just subtract the probability of that from 1, and you'd know what the rest of them added up to. So we want to use that idea and expand upon it a little bit to make a rule. So this is the probability of at least one rule. So when asked to find the probability of at least one something, right, fill in the blank, whatever that blank might be, then what you do is you find the probability of 0 somethings and you subtract from 1. All right, so I wrote that up here as the probability of at least one event E, call it E, in n trials is 1 minus the probability of not event E, right, to the n power. So you take the probability of not E in a single trial, and then you raise it to the n power. Now, this rule is a little bit tricky because you're combining together a bunch of things. You're really taking, well, the fact that the sample space has to add up to 1. You're also using the complement rule. You're using the multiplication rule. You're sort of using the addition rule a little bit to kind of make all this work. So it's very tricky because it's actually quite dense. It'll be written very simply, so it'll seem like, oh, this should be nothing. But they can actually be quite tricky, so you've got to be very careful. And don't forget, you don't have to memorize the rule. The rule is in your appendix amongst all your probability rules. This first semester, I accidentally left the old form in. So if you want to write the new form on your note sheet, then please do so. I'll eventually fix it so that it won't be there and it'll be written just like this. All right, so let's read this. The following shows the betting board for the roulette wheel at a casino. So if you go up to the table, this is what you place your chips on. So remember, you don't have to memorize any of the roulette bets. They're all in that appendix that you get given to you when you take an exam. So we start off with, why are the spins independent? Well, that's because the roulette wheel has no memory, right? It doesn't know what it spun last time, so it doesn't have any effect on what it's going to spin this time, right? Where the ball landed once has no effect on the next. Simple as that. Matter of fact, we used roulette wheels as an example of independent things when we were first teaching that. All right, so suppose we're going to spin the wheel 2 times in a row. You're going to place your chips on the 7-10 line, no matter what, for all spins. So whether you win or lose, you're just going to keep betting on the 7-10 line. What is the probability that you win on at least one spin? So we have a couple of things to note. One, we're talking about winning. That won't always be the case. Sometimes we might talk about losing, so we'll have to take note of that. 2 is that this is the number 2, so we know that our n is going to be 2 trials. And 3, we're talking about the 7-10 line, so we know what kind of bet we're placing, right? The 7-10 line, which is a line bet, which means you're betting on the 6 numbers that touch that line where that chip is at. So 7, 8, 9, 10, 11, 12. So I highly, highly recommend that you get used to, for these problems, figuring out what you want for one spin. So event E is winning on a 7-10 line, right? So let me type that up. So the probability of event E is the probability of winning on that 7-10 line. So when you look at the 7-10 line, there's 6 winning spaces out of 38 spaces total. And then not E, which is the complement of that, is 1 minus 6 out of 38. In other words, there's 6 winning spaces, so there's 32 spaces remaining that are losing. All right, now that is just to help us when we go to do the problem. Because when we do the problem, we want to think about for n equals 2 trials. So for 2 trials, we want to kind of expand upon that and use our formula. So the probability of at least one E being a win on a 7-10 line, would be 1 minus the probability of not E to the n power. So the probability of at least one, and I wrote out what E was. E is right here. E is the 7-10 win. So win on the 7-10 line. let me give it like a double underline or something. That's event E. So the probability of at least one E, right there, in 2 trials is 1 minus the probability of not E, right? The complement of E. All right, so that would be 1 minus the probability of not 710, but it's a win on 710. So that would mean I want to lose. If I'm not going to win on the 710 bet, then I'm going to lose on the 710 bet. So I need the probability of losing on 7 to 10, or that 710 line. Whatever that probability is, I need to raise it to the 2 power and then subtract from 1. But I already know the probability of losing because I already found it. It was 32 out of 38 because there's 32 losing spots and only 6 winning spots. So I need to take 1 minus 32 over 38 squared. Let me type this. 1 minus parentheses. Now you can just type 32 divided by 38, close parentheses, squared. And if you need a fraction, it will give you one. Or you can type it all at once. 1 minus parentheses, then hit the alpha F1 key. Again, only TID4s that have been upgraded can do this, but most of the 84s nowadays are upgraded. Not all of them, but you can always get it upgraded at the Center for Student Success or during my office hours or something like that. Or you can do it from the internet, just connecting your phone or your computer to your calculator. And there you go. So you get 105 over 361, which is about 0.2909. And there we have it. All right, so these are complicated. These aren't going to be super simple. We're going to have to work at it. So let's do another one. So this time we're going to spin 4 times. So it's going to be very similar to the last problem, but we're going to spin 4 times. We still are placing a bet on the 710 line, so that hasn't changed for this part. And we still want to win, right? You got to make sure you note that somewhere for gambling games, because I could also easily ask you about probability of losing. So I want to make sure you win on at least 1 right here. So that at least 1 is kind of a sign that this is what you're going to be doing. Okay, so at least 1. Great. So we already know the basics. We already know the calculations for 1 trial because we've already done them for up here. So I'll just kind of write that again. So the probability of winning is still 6 out of 38. The probability of losing is still 32 out of 38. That all has not changed. What has changed is that we're not dealing with 2 trials anymore. We're dealing with 4 trials. So all that's going to do is going to affect our powers for our probabilities. All right, so down here we're going to have n equals 4 trials now. So we still want to take the probability of at least one 710 win in 4 trials. So we want to take 1 minus the probability of not winning and raise it to the 4 power, not the 2 power anymore. So 4. So that means we're going to take the probability of losing and raise it to the 4th power. But the probability of losing is 32 over 38. So I just need to raise that to the 4th power. So let me try that. So if I use my up arrow, I can grab the old thing that I typed. Or you can hit the 2nd and then the enter button, and that'll get your last entry. And I'm just going to change my number up here from a 2 to a 4. And I get 0.49711. This actually is so yucky that it's not going to give us a fraction answer. So I'm just going to delete the fraction part and write that answer of 49 and some change. And there we have it. So we see how the number of trials affects these calculations. You still do the first part about 1 trial, right, at the beginning, and then you expand upon that for your 2 trials or your 4 trials, but the method still holds. All right, for this part, we're going to spin 3 times, so that's something to note. We're going to spin 3 times, and we're only interested in the 32-33 split bet. Split bet is when you take your chip and you split it between 2 numbers. So you're only betting on the numbers 32 and 33. And again, that is in the appendix. All right, now you'll notice this is not an at least one question. This is kind of a review question. What's the probability that you lose on one spin? But it's not telling you which spin you're losing on. So you're betting 3 times. So you could lose on the first spin, you could lose on the second spin, or you could lose on the third spin. So let's make a quick note of what it takes to win and lose, first of all. All right, so event E is actually losing. Because we're interested in loss, then the event we're interested in is losing. It usually pays with these kinds of gambling games to kind of note winning and losing. So the chances of winning is 2 out of 38 because there's 2 winning spaces. Then the chances of losing is the complement of that, which is 1 minus 2 out of 38, which is 36 out of 38. There's 2 winning spaces, so there's 36 losing spaces. Okay, great, wonderful. If we want to change this to events, this is actually not E, right? Because this is winning, right? Not event E is winning. And then event E was actually losing, right? So losing on that 32-33 split was event E. Strange, I know, because we're so used to winning being the event we're looking for, but it's not always. So in this case, it's not because they specifically ask us for the probability of losing. All right. So now we have to think about for 3 trials. So we've done the calculations just to kind of get ourselves ready, but now we need to think about 3 trials. And this is not an at least one, so it's not going to follow a set formula. So we have to think about, well, if it's one loser, then any one of the 3 spins could be the loser, could be the loss. So we want the probability of 1 loss in 3 trials. So it could be loss, win, win, or it could be win, loss, win, or it could be win-win loss. All 3 of those are possibilities. And you'll notice or means we're going to be adding. So we are going to add the probabilities up here. Well, we would. It's just that all 3 of them are the same, right? So it's really the probability of loss, win, win plus the probability of win, loss, win plus the probability of win, win, loss. All right, now how do you find one of those probabilities? Well, loss, win, win, these are independent, so you take the probability of loss, which is 36 out of 38, and you'd multiply it by win, which is 2 out of 38, and another win, which is 2 out of 38. So let me type all that up. All right, so that would be, for loss, win, win, that would be loss, 36 out of 38, times win, 2 out of 38, times win, which is 2 out of 38. Again, because they're independent, you'd multiply, right? Because this is a sequence of multiple events. So we use the multiplication rule. And then you do it again for win, loss, win, and then again for win, win, loss. So we need to know what that is. So we need to take our calculators and find out what 36 out of 38 times 2 out of 38 times 2 out of 38 is, or it's 2 out of 38 squared. So I'm going to type it that way. I'm not going to bother with the full fraction thing because I can always do it after the fact if I need to. So each of these fractions is 18 over 6859. So, and there's 3 of them. So let me type that up. All right, so then that would be 18 plus 18 plus 18 is 3 times 18. So 3 times that answer would be 54. Because 3 times 18 is 54. So our final result would be 54 over 6859, and I could find a decimal for that really easily, just so I have a sense of how big that is. 54 divided by 6859, enter. It's about 0.007. There we go. None of this was the at least one rule. It was all just review of the complement rule and the addition rule, and not the complement rule, the addition rule and the multiplication rule that we've already learned before. The addition rule gets us the plus signs because of the or, and then the multiplication rule gets us each of the 3 fractions that we need to multiply, and then when we multiply them, that's our final result. So in general, betting on that split bet is not necessarily a good thing. It's not doing so well for you, right? You got a 0.0079 chance of you're going to lose on one spin. Now you could lose on more than one spin too. So actually, it might seem like it's okay, but it won't be. Trust me, betting on a split bet is not a good idea. All right, so now the roulette wheel is going to be spun 3 times in a row. Fine. So far, this is all looking the same, except it's got the at least 1 bit right here. So that means that we're back into our rule. Since we're interested in loss, it's still that event E is losing. So event E is losing, 36 out of 38. Event not E, the complement, is winning, which again might seem backwards, but it just depends on your perspective. And we're still looking at a 32-33 split, so I can still use the numbers I found before, which is 36 out of 38 for loss and 2 out of 38 for win. But for this part, I want the probability of at least 1. So for that, I can follow my rule. So the probability of at least 1 is going to be 1 minus the probability of not losing on a 32-33 to the third power. So let me type it up. Okay, so our rule up above says that the probability of at least 1 lose on the 32-33 in 3 trials is 1 minus the probability of no losing on the 32-33 in those 3 trials. I realize my English is kind of terrible, but I'm trying to get across that lose is the event I'm interested in, so not losing is the complement of that. So I take the complement, not losing, and I'm going to raise it to the third power. In other words, I want the probability of winning, right? I want to win because all I do is win, 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 no matter what. No, just kidding. All right, so win on 32. I want to find the probability of winning on 32-33, and then I'm going to raise it to the third power. But we already know the probability of winning because we already found it. It's right here. The probability of winning is 2 out of 38 because there's 2 spots that are winners. So I'm going to take the fraction 2 over 38. I'm going to raise it to the third power. Okay, so I just need a calculator. So 1 minus parentheses alpha F1, hit number 1, 2 over 38. Close your parentheses, square it. Oh, no, not square it. My bad. Let me go back in there with my arrow. Third power. There we go. And I get 6859 over, or 6858 over 6859. Which if I find a decimal for that, 6858 divided by 6859. Oops. Too many 8s. 6858, sorry. 6858 divided by 6859. There, 0.9985. And there we have it. 99985, excuse me. Okay, so these are tricky. These are not super simple, right? You're going to have to kind of break them down. I highly recommend finding the single calculations first and then using those to drive your multiple calculations. Because once you have these pieces, they can help you from what you have to fill in down here. It also pays to really pay attention to what you're looking for as your event. Are you interested in winning? Are you interested in losing? What is it you're looking for? Because it's the complement of that that you're going to have to put in down here.